Part A, you will identify substances based on where they will fall in the total class cylinder. What we have for part A is H2O, which is a blue substance in this container. There is the methylene chloride at the bottom right here. It's important that you take note of the substance we are working with. I don't have the um, mineral oil and corn syrup, so you'll change things a little bit in terms of liquid substances. Here is the hexane. All right, this is the hexane liquid. This is the ice, and I don't have the class marble, but we will use, or I'll use the class stopper. This is the rubber stopper and the coke right here. Your job is to identify each liquid substance based on where they will sit in this tall class cylinder. I will start by the two liquid substances in this container. I do have the blue, which is water, and methylene chloride, CH2Cl2. And what I'll do is just put this in the tall graduated cylinder. Yours is to identify where they will fall. So right now what I'm doing is just transferring the two liquid substances into the tall class cylinder. You'll identify the liquid substances as in L1, L2, and L3 based on where they will fall or where they will sit in the cylinder. So right now I do have two liquid substances. Take note of their names. The blue one is H2O, and this one methylene dichloride. I'm just gonna have that sit for a minute, and next I will add the hexane. All right, hexane is the last liquid substance I'm going to add, and your job is to identify where they will sit. So this is hexane. I'm gonna add hexane layer, and your job is to identify the three liquid substances, the last one I added is hexane, and the first two which went in there are methylene dichloride and H2O. Next, I will add the solid substances. Let me add, start with the I'm gonna start with the class. See where it's gonna fall in there. Let's see where it is. I think it is somewhere there. You can see the class stopper is somewhere right there. So you gonna indicate in the data sheet. This is the stop. This is the cock. Okay, it's a wooden cock. You see where it is. I want you to label on the data sheet. Right now, I'm holding the rubber stopper. You will also indicate where it is on the, where will it sit on the liquid substances. Where will it be? Lastly, what I'll add in there is the ice. I have ice here. You just have to indicate where it's going to be. Hopefully it's going to be visible from where you are. Right now, this is the ice cube. I just added the ice cube, and your job is to label where the four substances are. Rubber stopper, the class, and ice, and the wooden plane. Please indicate in your data sheet before we move on to part B. Part B is determination of density of H2O, and there are two trials. Trial 1, we will use LMR flask number 1 and LMR flask number 2. For trial 1, you will record the data based on the centigram balance, and trial 2, you will record the data based on the milligram balance. On the data sheet, there is two columns. You will have to fill in according to the information given. Here is the information you will need to have for centigram and for milligram for trial 1 and trial 2. What I want to do is determine the mass of LMR plus number 1 with the rubber stopper. And right now, the centigram balance is 0, so I want you to record the mass of the rubber stopper LMR flask is the empty, and in trial 2 you'll record the mass of LMR flask number 2. Make sure that it is 0, 0. Yes, it's 0, 0. Let's record the mass of LMR flask number 2 with the rubber stopper in your data sheet, and then we will measure 10 ml of deionized water using the 10 ml pipette. We will fill the 10 ml pipe. We'll measure our 10 ml of DI water using a pipette. This is called a pipette. It has been calibrated to deliver exactly 10 ml. If you have the you pipette your reagent or any solution, in this case H2O, if we have the meniscus just right there by the calibration mark, we will deliver exactly 10 ml. Later on, in upper level courses, you may use different pipettes with different capacities. I mean, there are 10, 15, there is even 5, even lower than that. But understand how this one works. You can fill using the pipette bulb or the pipette filler. Next, we will fill our 125 ml flask with 10 ml of DI water. Make sure you don't mix the rubber stoppers. The direction calls for conditioning the 10 ml pipette. What I want to do is do what we call conditioning, and conditioning is just filling with just few ml of water or any reagent. You just press the hard valve and you release it gently such that you pipette the liquid substance, in this case H2O. And using your thumb, you can stop. What I'm doing right now is conditioning the pipette with the liquid H2O, and then dispense it in a waste receptacle. I'm just now conditioning, and with my bulb, alright, this is the bulb used to fill the pipette. I will measure out exactly 10 ml of H2O, 10 ml of H2O, and transfer it onto LMR flask number 1. Sometimes you may not pipette all the way. You can use your thumb to roll that, squeeze it again, mount the pipette filler or bulb. The meniscus is rising, it's not all the way up there. I see still not all the way up there, so I'm just gonna do it over and over until I have the meniscus just right there by the calibration mark. It's not yet there, it's not yet there, it's still going up, 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 up. It's past that, so I need to fill one more time. Let's see how far it's gonna go. Yeah, it's gone past that, that's fine. It's gone past that, so what I'll do is I'll adjust using my thumb until the meniscus is just right there by the calibration mark. I'll just release slowly, 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 stop right there. If you see clearly, the calibration mark is just right there. I will transfer it either number 1 or number 2. You don't need to blow, right? If a small drop remains in the pipette, just leave it. That's how it works. This is LMR flask number 2. We'll do the same thing for number 1, all right? You don't need to blow the pipette. So this is ready. I'm just gonna place the rubber stopper for trial 2. Let's do trial 1 again. What I'm gonna do is trial 1. I'm just gonna pipette all the way to the calibration mark. It's not yet there. So I'm just gonna remove, squeeze it again, all right, and pipette all the way. All right, let's just see where this will stop. Oh, I didn't get it. So I gotta do it over again. Yeah. Alright, it's almost there. Let's just go past that. I can just take the meniscus past that and use my thumb to control the meniscus. So it's past the calibration mark. Just release the air slowly. I got it. All right. So I will transfer my 10 ml to trial 1. This is 10 ml of deionized water. And then remember, for trial 1 we will use centigram balance. And for trial 2 we will use the milligram balance. So take the wall. This is let me erase it here, and this one I have it right here. And what I'll do is measure the mass of trial 1, trial 2. This is trial 2, and this is trial 1, trial 2, trial 1, trial 2, trial 1. Please record the masses of trial 1, trial 2 on your data sheet. Part C is the same as part B, except you know, we will replace a known substance with we'll replace the liquid H2O with the unknown substance B. This is not a known substance B minus, but it is a known substance B, indicate in your data sheet. And just like before, we will record the mass of LMR flask label number 1 using the centigram balance, and LMR flask number 2 using the milligram balance. So let me start by just zeroing the balance on centigram. Make sure that it is 0 by pressing the 0 button. So what I'll do now is record the mass, or weigh the empty flask by itself. You can record the mass of LMR flask number 1 or trial 1, and for trial 2 we will do the same thing. We will do the same thing for sample number 2, and what I'll do is this place right here. Your job is to record the mass of empty flask. Next, we will pipette just like before. 10 ml of unknown sample B into flask number 1 and flask number 2. We'll record the mass of the LMR flask, rubber stopper, and the unknown sample into 2 flasks, and we calculate the density using the equation in the lab manual. Just like before, we will do the same thing for unknown liquid substance. I will pipette 10 ml into LMR flask number 1 and 10 ml into LMR flask number 2. This is the unknown sample B. I'll pour it into the 50 ml beaker. This is where I will pipette the 10 ml of our sample. Just like before, I will have to condition my pipette. Alright, I'll condition the pipette with few ml of unknown substance. Make sure that it is conditioned and ready for our sample. So that's where I have the sample in there. Look like maybe I didn't get it well. Nevertheless, that's the sample. This is LMR flask number 1. So I'm just gonna get the 10 ml of unknown sample P. It didn't go all the way, so I will pipette again until I have the meniscus just right there, just by the calibration mark. I still need to pipette. It's not easy, but we'll take. I'm just gonna control the meniscus. I'll control the meniscus until I have just by the calibration mark right there. Look like what you do again. Let me just get there. It's went past the calibration mark, so I need to control the meniscus. It's dropping all the way to calibration mark. You want to be precise and exact. So I have my 10 ml into LMR flask number 1. This is trial 1. We will use the centigram balance. We will use centigram balance for trial 1. This is for trial 1. I'll do the same thing for trial 2. Remember always not to mix it up as toppers, okay? So this is for trial 1. I'm just gonna keep that. We'll do the same thing for trial 2. I'll do the same thing for trial 2. Alright, trial 2. We didn't get it right, okay? We repeat it until we have the meniscus just by the calibration mark. I can go past the calibration mark and use my thumb to control the meniscus. Oh, went past that. I got it. The calibration mark is down here. The meniscus is up here, so I'm gonna control the meniscus by letting the air in. I'm just gonna let the air in. I'm just gonna get the air in. Slowly, it's dropping. The meniscus is dropping. right there. I have the meniscus by the calibration mark. So what I'll do is transfer onto my LMS plus number 2, and I'll use the milligram balance to measure the mass of the unknown sample and the rubber stopper. I'll stop it and measure the mass, record the mass using the milligram balance. So we are done with this. If something remains there, that's fine. If something remains at the bottom, that's fine. I'm just gonna place this one in a safe place. Stop at this one, and I will use the milligram balance to, I mean centigram balance for trial 1 and milligram balance for trial 2, and you'll find the average of the two. So the milligram centigram balance for trial 1 and milligram balance for trial 2. You record the mass of the masses on the correct column. Trial 1 for centigram and trial 2 for milligram. Find the average following the guidelines or the rules for addition with respect to maintaining the correct number of significant figures. In part D, you determine the density of number 2 rubber stopper. I do have rubber stopper number 2 here, and we will do 2 trials. This is for trial 1, this is for trial 2. For trial 1, mass will be taken in centigram balance. For trial 2, we will use the milligram balance. Initially, you'll have to record the initial volume of the water in the 100 ml graduated cylinders, and we will weigh or record the mass of each of the rubber stoppers for trial 1 and trial 2. What I want to do is just place this one aside for trial 2. We'll come back to this later. Let's start by recording the mass of rubber stopper number 2 for trial 1. That is the mass. Please record on your data sheet. You'll record the volume of water in the graduated cylinder for trial 1. Please make sure you record the volume to the exact place of decimal. You need to read the meniscus. There is the initial volume. You have to see where the meniscus is. I think you can see from where you are. Record the volume, that is the initial volume, before we place our rubber stopper number 1 on the balance right there. I have for trial 1, I have the rubber stopper at the bottom of the graduated cylinder in there. You need to record the final volume in the graduated cylinder. You can see where the meniscus is. If you want, you can stop the video and see where the meniscus is on the graduated cylinder. This is trial 1. You need to record the final volume for trial 1 in the graduated cylinder. For trial 2, you will record the mass of rubber stopper number 2 using the milligram balance. You'll record the mass using the 3 places of decimal or the milligram. That is the mass of rubber stopper number 2, trial 2. Next, I will fill the second graduated cylinder with deionized water. All right, I'll fill the graduated cylinder with deionized water to some initial volume. It's not necessarily 60, it can be somewhere, so long as you know the initial volume of, I'm just agitating so that you can see where the meniscus is. Record the, please record the initial volume to the exact place of decimal, all right? You need to record the exact volume, that is your initial volume, before we insert the our rubber stopper in the graduated cylinder. Rubber stopper number 2 is in the graduated cylinder right now. The volume rose to somewhere there. I don't want to say. It's your job to determine the exact volume. You need to record the exact volume in the graduated cylinder. That will be your final volume. That is your final volume of H2O. And that marks the end of part D of our experiment. We will move on to the next Part D is determination of density of a known solid, and a known solid you are working with is a known solid C. This is the unknown solid C, which you need to record the mass in centigram, or using centigram parlance, and using the milligram parlance. Please record in your on your data sheet, that is the mass for trial 1 or column 1 in your data sheet, and for trial 2 record the mass in column 2. This is milligram parlance. Please record the mass in milligram. You'll find the average, or you use this mass to find the density for trial 2. There's trial 1 and trial 2. Trial 1 is based on centigram parlance, and trial 2 is based on milligram parlance. Next, we will determine the dimension of this unknown object using the metric ruler in the data sheet. Next, we will record or we will measure the length, the width, and the thickness of the unknown solids. Please record in your data sheet right now. I'm just placing the unknown solid next to the metric ruler in the lab manual. Your job is to record the length of the unknown solid to the exact places of decimal. Please look at the end right here. We have the how many places of decimal you should record your measurement of length. Let's try and see the thickness. That is the thickness. You can also record the mass, I mean the length of the unknown solid. The length, or I mean the thickness. What's the thickness? The width, I don't know if it's the same thing. That's gonna give you the same value for volume. You know, volume by calculation. Length times width times the thickness. Please record the thickness as well. All right. I know there is a shadow, but hope you can be able to see the thickness. In part F, you'll collect the data to determine the thickness of the aluminum foil. This is the metric ruler, and there is no way you can use this metric ruler to determine the thickness of the aluminum foil I do have here. But you will make use of the density equation, and the literature value for the density of aluminum foil is given on page 20 in your lab manual. Density of aluminum is 2.70 grams per centimeter cubic. What you will do in this section is just find the area, which means you'll collect the data to determine the area, that is the length and the width. And right now, I'm just gonna place the aluminum foil on metric ruler, the metric ruler on figure 4, and you will collect the data. Please record the width. This is the width of the aluminum foil. Record the width. Next, I'm just gonna flip over and you will record the length. This is the length of the aluminum foil. You will use the density equation to find the thickness. That is the length. All right. Hope you are able to see the scale on metric ruler B. What I'll do now is I'll fold this into 4 parts. This is or twice. This is the first folding, and I'm just gonna fold it again, and you'll record the mass of the aluminum foil, just to make sure that it is sitting properly on the pen, on the balance. I'm just gonna fold it like that. So we will go to the weighing station and record the mass of the aluminum, and you should be able to find the do the calculation for the length. Next, you'll record the mass of the aluminum foil. Let me just zero the balance, make sure that it is 0, 0. I'll place the aluminum foil on the pen, close the door. I want you to record the mass of the aluminum in your data sheet. This is the mass you will use for your calculation. It things around 0. All right, I don't want to say. I know you can see. All right, and that marks the end of this map. Thank you.